Alrighty. Hey, gang. Welcome back, you guys. Episode 47 of Stove Chat. I'm Matt, as always. And welcome to another episode, Walker Stove's Stove Chat. How you guys doing? Hope you guys had a great week. Happy Wednesday, everybody. Welcome back. So I am a little bit, as usual, there we go. I'm just kind of still playing with stuff here, getting things dialed in. I kind of was messing with stuff right before the show, so bear with me if I have some technical difficulties as always. But yeah, how you guys doing? Hope you guys had a great week. Couple weeks. Hope you guys it's been a few weeks since I've seen you, so hope you guys have had a good couple weeks. Getting some firewood up and getting ready for the fall. It's starting to cool off here for sure. I even saw some smoke coming out of some chimneys this morning. It actually was almost in the 30s this morning. My house was right around 40. But I know it was chilly for some folks down in the lowlands and whatnot. So good morning, everybody. Nice to see all you guys. Thanks for being here, everybody. Tall Shadow, Two Trance, Fred, good to see you guys. Thanks so much for being here. Got a pretty good show for you guys this week. Got some good stuff to look at. Got some great photos from some of you guys. Really appreciate all that. And as always, as you guys know, I'm Matt with Walker Stoves, and on my website, which there's a link below, walkerstoves.com, I've got plans that help you build rocket stoves, rocket mass heaters, cook stoves, all kinds of solid fuel burning cool stuff. And we're here to talk about tips and tricks and science and technology and how to build them and stuff like that. So if you're here and you have any questions, by all means, please throw them in the chat. We'd love to have some topics for discussion, and there's a great crew here that can help you if you're working on parts of your build, aspects of your build, and have some issues to sort out or things that could be improved. This is a great group to do that for you. So there's the intro. Mark, good to see you. Glad you're here. And let's see. Fred says still an extreme fire rating. Yeah, totally. We can't burn here at all. I'm close to you. I think Fred on the Sailor Sea as well, and burn bans everywhere. But I saw chimney smoke this morning in someone's house. But outside, burn bans all over the place. So, knock on wood, we've had a really nice summer out here on the coast where I am. With regards to smoke, I talked about that in the last show, but we've had very little wildfire smoke, which has been nice. A nice change from the last few summers. So yeah, so there you go. So first order of business for today, you guys, you may have heard I got this news. Hey Robin, welcome. Got this news a week ago or so, but earlier in the month, Dr. Larry Winiarski passed away. And I thought it'd be a great time to honor him. We've talked about him a bit here. Those of you who don't know, Larry Winiarski is really the father of the rocket stove. He was a doctor, a PhD with a doctorate in, I believe, mechanical physics or mechanical engineer. He was born in Honduras, and then his family moved to Kellogg, Idaho in like 1948 when he was like 1 year old or something like that. I'm going to kind of get the details a little fuzzy. But moved to Kellogg, Idaho in the late 40s, which I thought was so cool. I mean, can you guys imagine? I don't know if you know much about Kellogg, Idaho, but I've spent a little bit of time there. You know, it's a little town right outside of Sun Valley. And right then in the 40s, early 50s, Sun Valley was kind of the first, ski area where the Hollywood stars would go and all that. It seems such a cool time and place to be growing up. So he grew up there and then moved around a bit. I think he worked for, I'm gonna forget, I don't think it was Lockheed Martin, but it was one of the Raytheon, maybe one of the major defense contractors, engineering, before he moved to Oregon and started doing the work that would eventually lead to rocket stove work. And I think I will take a quick look at his obituary here, where they give a lot of the details. Yeah, he moved to Oregon, where he worked for the EPA, it sounds like. And in that part of process of working for the EPA is when he came up with the principles of the rocket stove. I hope it says I'm not giving you guys enough data here, but hopefully you guys will catch me. Hopefully I'll just have some little dropouts and we'll pick back up. But at any rate, Larry Winiarski is really the foundation of why we're here. He established so many of the principles of rocket stove combustion. He designed the J-tube rocket stove. He designed, I think, the very first cooking rocket stoves as well. He's just an enormous figure. In his later years, he worked with other doctors at the Provecho Institute, which is Appropriate Technology Institute, and I'm trying to find the other fellow's name, and I'm gonna miss it, but at any rate, he worked with another fellow who came up with the idea of pot skirts and keeping heat in around cooking pots. And together they developed what really today are kind of the foundation for so many humanitarian efforts and so many humans across the globe. The basis for what they cook on these days was founded on Larry's work. And so what I was trying to describe there was the institutional heaters. It's sort of the evolution of the cooking rocket, where we went from sort of L tubes with just a pot sitting over the top, and then maybe J tubes, but where eventually they started to sink that pot down. It started with just a pot skirt and basically sinking the pot into an insulated chamber so that the flue gases can completely surround the pot and heat it from all sides from the bottom in a contained fashion. And in the course of doing that, these guys really revolutionized, prior to where we are now with our heating stoves, they really revolutionized the way people cook all over the world, millions and millions of people. And in doing so, had an enormous impact on air quality in areas where people do cook with solid fuel indoors, usually in poorer countries, and it always had a horrendous effect on people's health, both indoor air quality and outdoor air quality. So the work that he did was just, enormous. And then on top of that, Yanto and others came along after him and adapted his work with these cooking combustion chambers to our, thermal mass, what we talked about before, putting these types of ultra efficient combustion chambers into what were, traditional masonry heater bodies, and kind of coming up with what we believe are, the ultimate in efficiency with regards to home heating, efficiency and comfort and cleanliness and all of those things. So really a big deal. Larry's work, his life, and his, everything he contributed. So as Tall Shadow says, thanks Larry for helping to pave the way for Stove Chat and all of us to be where we are. So I thought that was, a really important guy to honor. And if you get some time, give him a quick Google. He's got a ton of, as I started to kind of search for stuff to talk about, to give some background to what we were doing here, I realized kind of the breadth of his reach. And you'll see just variations on his cooking stoves all over the place. One of the main contributions was he came up with what he calls the 10 principles of rocket stoves. And the idea was that these would be simple, like commandments almost, that he could convey to the people doing the cooking in these third world and various different cultures. He wanted some simple rules to convey to these people so that they could create their own stoves cheaply and easily. And those 10 rules are pretty interesting. They really dovetail nicely with everything we know. And I think we've done these before on the show, but I'll go over one more time because they're so they're just so relevant to what we do here. So the 10 principles of rocket stoves as according to Larry Winiarski. Now keep in mind, this is specific to cook stoves. Now at the beginning, there's some things that are universal that we could apply to our heating stoves as well, but after a while he gets into kind of specifics for his sort of L-shaped cook stoves as opposed to our J's and whatnot. But rule number 1, insulate, particularly the combustion chamber. So I, of course, find that one particularly poignant. I love insulation around the combustion chamber. And in the combustion chamber, you guys know that's one of my main sticking points, and one of the things I've fought really hard to bring to the forefront. Obviously it's not my rule, it's Larry's rule, but I think that over the course of time, it's so easy to build stoves with heavy bricks, high mass, that somewhere along the way that rule sort of got a little bit diluted maybe. Anyways, we know now that is rule number 1, and it's important. It is probably the most important rule. So insulate, particularly the combustion chamber. And then rule 2, use an insulated upright chimney above the combustion chamber of a height 2 to 3 times the diameter. So he's starting to lay the foundation for the ratios that we use to design rocket stoves. So he wants the riser, the insulated upright chimney, above the combustion chamber to be 2 to 3 times the diameter. So if it's a 6-inch chimney, we want it to be roughly 3 times 6 or 18 inches, which if you put that on top of a 12-inch combustion chamber, you come up with 28. So that's those are the basics for a cooking stove. And we've, of course, stretched those a little bit, but that's the beginnings of the rule of thumb. His rule 3 is heat only the fuel that is burning. In other words, don't heat a whole bunch of fuel outside of the firebox, which is the original design for those rocket stoves and J tubes with the sticks sticking out. You just have the combusting fuel down deep and the rest of it up and out of there. Maintain good air velocity through the fuel. That's rule 4. So that one we achieve by maintaining good draft throughout the stove, and by maintaining cross-sectional area everywhere within the stove. Number 5, do not allow too much or too little air to enter the combustion chamber. Strive to have stoichiometric combustion. So stoichiometric meaning chemically ideal, or the perfect balance between air and fuel. Number 6, the cross-sectional area of the combustion chamber should be sized within the range of power level of the stove. So that's pretty vague. And he says 25 square inches will suffice for home use, which, as we know, a 6-inch chimney is roughly 29 square inches. So he's right in the ballpark there for a 6-inch chimney. And now he starts talking about cooking stoves only. So now he's talking about elevate the fuel and distribute airflow around the fuel surfaces. When burning sticks, it's best to have several sticks close together but not touching, leaving airspace between them. That's accurate for most stuff, but the elevating the fuel doesn't really fit our new types of rockets. Arrange the fuel so that air largely flows through the glowing coals. We do that in our stoves, very much so. Throughout the stove, this is rule 9, throughout the stove, any place where hot gases flow, insulate from the higher mass of the stove body, exposing pots only to direct heat. So this is a pretty neat thing here. He's saying insulate everything except for what you want to get hot. So in the cooking stove, he's talking about the pots, sunk down in an institutional type stove. But this applies to our rocket mass heaters and cook stoves as well. I've been doing quite a bit of consulting lately with folks who are building stoves, and one of the best ways that one can tune a stove to different locations, needs, or whatever is by using insulation in areas where you might want to protect heat or to send heat farther downstream. So for instance, a regular J tube, the blast of hot gases come out of the top of the riser, and typically we put a cooktop or a barrel over the top and we get heat right out of the top. It's also possible to insulate the top, redirect that riser gases towards the front, and then use a metal radiator, and you can actually get stoves to radiate out into the room like that horizontally. And so that's an example of using insulation strategically to direct the heat where you want. Now you could go on and on with that. You can insulate along tops to push heat downstream into benches. You can use insulation to allow you to be able to put cores, combine them underneath materials that might otherwise not work out. So there's a lot of ways to do that, but he's really identifying some crucial elements that we use all the time to tune and customize builds to fit people's goals. And that really is the idea of using insulation strategically. And we have so many options and such great options now. We still have our simple hippie stove type insulation, perlite and clay, or wood ash, things like that. But we now also have ceramic wool, ceramic fiberboard. There's a lot of ways that you can change where the heat goes inside your stove. So I thought that was really cool that Larry identified that really early on. And of course, for making an efficient cook stove, that would be of utmost importance. And then his rule 10 is transfer the heat efficiently by making the gaps as narrow as possible without choking the fire. And again, this is fairly cook stove specific, and he's referring specifically to the gap above the riser to their large stock pot. So he's going to try to get that thing as close as possible without restricting the flow in an effort to heat up the whatever's in the pot as quickly as possible. So those are the 10 rules of rocket stoves as per Larry, and what a great gift he's given us. So let me catch up with Chad. I want to say hi to Jacob real quick. Nice to see you, Jacob. Thanks for being here. And Melissa, so glad you're here. Fantastic. Great to have you here. All right, so got some newer folks in the chat. That's wonderful. And let's talk a little bit about, while I was just talking about insulation and tuning, I'd like to talk a little bit about modifying stoves to fit your space and fit your needs. One of the things that comes up often in these discussions, yeah, good, Melissa. Strategic insulation idea. That's fantastic that it fits your bill. And I mentioned earlier, if you missed it, Melissa, we are here to help folks who are doing builds and to have a group that can help you if you have any questions. So by all means, feel free to jump in. You're not interrupting. If you have questions, something you would like answered on your build, throw it right in here, because that's really what makes the best shows is when we're actually helping people solve real-time problems. So feel free to throw questions in there. And with that said, I will just go right back into what I was talking about with regards to modification. I was just talking about insulation, and then I was segueing that strategic insulation discussion, segueing that into a conversation about ISA, or internal surface area, and the concept of sizing a stove when you're in the design stages, with regards to not necessarily sizing it to fit your space, but with regards to what are your limitations, physical size of the body of the stove to size of the core's output or whatever. And so Peter Vandenberg has a pretty neat technique, I guess, of sizing stoves, where he uses that internal surface area, and he has a fixed number of internal surface area that he matches to a certain size combustion core. So he has like a oh, hey David, nice to see you. Thanks for being here, man. So he has like a 6-inch core sized to X amount of internal surface area. It's a very reasonable way to go, because it just sort of puts people right in the lane of what's going to work. Now, we've talked about this before, but I will repeat that Peter believes in building stoves with no bypasses. So the stove needs to be able to start from cold and have enough heat left over after traveling through the mass that it still has enough heat left over to create draft. With that said, he also believes that a masonry heater should be burned once hot during the day, and then ideally it gives off its heat over time without additional fires to charge up the mass. So the whole thing is sized to basically be burned once with one load of wood, let go out, and then 8 hours or 12 hours later have another fire. Now that's with no bypass. Now those things are important to the size discussion Because as you guys know, when it comes to sizing stoves, I have a much more cavalier approach where I say it isn't as critical to match the internal surface area of the masonry to the core size, because what we can do is we can install a bypass that allows hot gases from the core to bypass the thermal mass so they can miss all of that and go straight into the chimney, holding heat, maintaining heat for draft, and allowing us to manage the stove through startup, through different outdoor conditions, things like that, to provide constant, clean combustion with high quality draft, but also manipulate it so that the gases start to pull through the mass and heat it up. And in doing that, we can now have multiple burns back to back and have a larger mass than we might be able to have if we didn't have that bypass. If we had too big a mass and no bypass, when we try to start the stove, those hot gases go into that mass, and since that mass is so large, those gases are cooled completely before they find the chimney, and so they therefore settle to the bottom of your mass and they will not come out, and you get a cold plug in your stove, starts smoking out the door, and it doesn't start. And so by having that bypass, we can have a large mass, we can avoid overcooling the gases on startup, and as the gases start to get warmer, we can start to close the bypass and manipulate it to let air, to let hot gases into the mass and start to heat it up. And as it starts to heat up, we can start to close the bypass more, and because now we're maintaining draft. This is all stuff we've covered before, but what I really want to bring up is the idea, or the way that concept allows you so much freedom in your build. You can grow your stove's bells, you can grow the body of the stove, you can mirror them one way or the other, you can elongate one side or the other, you can do all those things. Now, one of the most crucial questions I get is there a limit? I want to build this thing to fill this X space, and I don't know if that is going to work. I'm not sure how well that's going to work. And this is where, now I'm going to segue into the new part, this is where the strategic insulation really comes into play. And where it goes and how much you need and how you use it, you probably won't know exactly the first time you build the stove. So let's say someone took my Continental cook stove and they stretched it way out because they wanted, to have it fill a space, to have it fill a room, and they wanted a long workspace down the hall or something like that. And they really want it to heat from the center of the house. Can you do that? And the answer is yes, you really can, up to almost any size. Now, obviously within reason, it can't be any size. But if you were to just take those bells that were too big and insulate them, even just doing that, you will maintain so much more heat in the exhaust that you should be able to, maintain draft, depending on how big the thing is. Obviously, we're just talking about, sort of broad concepts. But one of the coolest things about this is that now you can build a stove that's kind of too big, fit it into your space, and you can use that insulation to get it to rest of the stove. Is it going to be cold? No, it's not going to be cold, but it's not going to blast heat out. But if you're building these stoves and using them the way I do, which is I burn them much more often than one time a day. When it's the dead of winter, I have it sized so that I can have a nice fire most of the day. And if you're doing that, eventually that whole thing is going to get warm, and you're just going to have that much more mass, that is holding your house at temperature. Now it takes kind of a high delta T between the inside temp and the temperature of the stove to heat the house. So that's why we like the cooktops on top. They'll be at 800 degrees or whatever, and they're really heating the air and moving it around through convection. So they're really heating your space. Whereas the body of the stove, they can do some heating, but if you have a really cold needs outside, it doesn't do so much heat. But what it does is it's a great flywheel. Really keeps things from falling off once the house is warm. So combining those things, that, you know, the cooktops or the barrels or whatever, and then these larger masses that you can control that allow you to feed heat into them for hours and hours and hours, you can come up with some really, really, really neat designs that sort of exceed what you might think is possible. And one of the key key things that allows you to do that is insulation used strategically to push heat where you want it and retain heat to get it to the chimney. So let me catch up with chat here. Yeah, David's here. That's great. Go tell him Willie Boy's here. Your name is hard to say there, my friend, but nice to see you from England. Tall Shadow says a bypass is like a turbo boost to really help kickstart a cold stove, or just get a good blast of heat if needed. Wouldn't be without mine. Eliminates smoke back almost 100% of the time. Yeah, that's been my experience too, Tall Shadow. I find them invaluable. And of course, in the cook stoves, they serve another function that some folks not important, but other folks mandatory, and that is that they will work as a summer bypass. So using one of my cook stoves in the summer, you can pull that bypass and the heated gases will heat the cooktop so you can cook your food, but then go right out the chimney and not heat the body of the stove so you don't overheat your home if you are doing a full off-grid summer kitchen kind of living situation. That's an enormous help, you know, not heating the stove or the house while you're cooking. So great input there, Tall Shadow. So hey Ryan, nice to see you. Thanks for being here. And then Jacob asks, have you tried different types of chimneys, longer, shorter, and different materials used for chimney as well? Yeah. Definitely have tried many types of chimneys, longer, shorter, insulated, non-insulated, brick, metal, tile. Excuse me, quite a few chimneys. And what I will say about chimneys is that what type you use, I think, really depends mostly on what's available to you and what your goals are. In my opinion, the very best way, and of course I can't say very best because it's going to change with certain situations, but for most people who aren't starting from scratch and don't want a massive masonry project, ideally the stove is designed with all of the thermal mass kind of in the stove, and you're outputting out of the stove body the minimum temperature of exhaust. And then in order to keep that minimum temperature of exhaust, to retain the temperature through the chimney, you know, I think the very best chimneys really are insulated chimneys, kind of like what they use in normal wood stoves. They're overkill, to be sure. They're terribly expensive, those triple wall insulated chimneys. And we don't need the chimney fire protection in our stove because we can't creosote up a chimney. We really can't get ignition temperatures or sparks that far downstream. We really can't have chimney fires in our rocket mass masonry heaters. So the triple wall chimney is overkill, but with that said, just an insulated, highly insulated chimney is really the ultimate, in my opinion, because you can keep your mass down low, try and keep all your heat in the stove, and then just send a little bit up the chimney, and the insulation helps maintain that little bit of draft all the way up to the top, so that at the end of a longer chimney you have greater difference in temperature in addition to the pressure difference due to elevation, and you get better draft. So to circle back on your question, taller chimney is almost always better. Longer chimney, almost always better. I believe that probably is accurate to a point. It's possible to have too much draft, but there's ways to mitigate that, much easier than not enough draft. So I think longer chimney is best. And then different materials. And again, like I said, it kind of goes back to combustion chamber in terms of materials. No mass is best, you know, like if money was no object, you'd build your chimney, in my opinion, out of like ceramic fiberboard, just like a riser, like do it like a 5-minute riser or something, because that would be the best performance. But barring that, we've got other options. Single wall metal, that's what I use. It works fine, but it sheds a ton of heat, So if you were in a situation where you didn't have any heat to give up, then the metal wall, single wall chimney's gonna shed a ton of heat, and you're gonna end up with condensation. You'll get a chimney plug. Tile, chimney tiles, those round or squared with rounded corners, chimney flues, or brick chimneys. Same thing, you got mass in the chimney so it can cool the exhaust gases, not probably always what you want. Is it acceptable? Yeah, probably, if you design the stove such that you maintain a little heat, and eventually those flues become warm and they retain heat like thermal mass, and then they're driving the draft. So, pros and cons on all sides, compromises here and there, a little bit of different performance. So, and then Jakob goes on to say that, he says, I think one of the guys from community somewhere was pushing chimney gas temps to like room temp and still maintain draft to maximize energy taken from RMH. Yeah, and I'm sorry, I'm probably pronouncing your name wrong. I said Jacob, maybe it's Jakob. I had a friend named Jakob, so that's probably how you pronounce it. But you got it exactly. He's idealizing, and when you first learn about the concepts and you start to understand that you really want your chimney gases as cool as possible, it's really, that's the first thing you grasp onto is like, oh, good, okay, let's get them at room temp or whatever, as cool as we can. What you find out after, using these things for so long is that you really need to maintain a certain amount, and it's not something that you don't want to live on the edge. It's fun when you got the tester out to get it as efficient as possible. But in the real world, that little bit of efficiency that you gain from cool chimney temps equates to actually a lot lower efficiency overall, because there's times where the draft just isn't adequate and you're not pulling enough air through the combustion chamber, or it's starting to puff smoke back, or you're just living on the edge because you really want it going right, like just one direction, pulling really hard this way, pulling through there, and as soon as this starts to slow down, so does this, and now you kind of got problems with combustion. So in my opinion, the draft is important to maintain at an adequate level. I don't try and get my ultimate efficiency there, and that is where the bypass comes into play, because you can have a broad range of performance modes, as it were, depending on conditions, and you can put heat in the chimney when you need it and then cool it off and shoot for the the ultimate efficiency, maybe oversize your bell, and then you could always sort of keep your chimney temps close to the peak or minimum temp, and then just give a little more juice if you need a little more draft and the wind's blowing down your chimney or whatever. So, the other side of that coin is that, like in Yanto's book, when he was first describing these rocket mass heaters, he'd come up kind of with the whole concept, and he was going for ultimate efficiency, and in the book he talks about, just exhausting out the side of the wall like a dryer. Just a horizontal exhaust is basically just spilling out of his bench cold. Excuse me. And, while that's entirely possible, and like I said, from a purely physics standpoint, you get excited about that. Like, that sounds awesome. And Yanto was, hardcore enough to make it work. He was like, this is fine. I can make this work and get ultimate efficiency. But for most folks in the real world, a little gust, a little puff of wind, things the wrong temperatures, and it's a reverse chimney, so if things are going the wrong way, you're gonna just have huge plumes of fire into your house. And in my early days, when I built my first rocket stove and put it in my house, I did have that, and I'm telling you, it's terrifying. Especially when the thing's loaded with wood and burning super hot, and then a gust comes and makes that thing backdraft. I mean, I had flames that would shoot like up to the ceiling. It just literally looks like a dragon. That's why they named it the dragon. When a J-tube backfeeds, and it gets fresh air feeding it from behind, blowing into your space, it's terrifying. So, yeah, I as close as you can get to that balance is the ultimate efficiency, but you have to maintain, in my opinion, that solid draft to keep things running good. And Jeremiah throws up some really good info. He says particulate buildup at lower temps, and over time it needs blown out as well. So same thing, like if you just don't have enough draft going through the stove, you start to really, really, really build up everywhere. You're not carrying things out of the stove, and mostly that translates to really just kind of poor combustion in the front end, especially if you're running really slow in terms of draft. You just don't have enough air, to run the combustion. So okay, so that's probably let's see. Let me catch back up and just make sure that we talked about all the chimney stuff. Yeah, I think so. I think let me just wrap that up real quick. So to answer your question, for most of my builds, what I like to do is use, I will try my hardest to salvage triple wall insulated chimney flue pipe, and I will use that on every part of the chimney that's outside. So I will use that like from the roof up, or if I go out through the wall, like from the wall out and up. Now, ideally, if you had enough of it, you'd use it for the inside section too, but it's terribly expensive, and I think that for what I do, typically what I do with the build is I will just use single wall flue pipe from the stove to the ceiling thimble, and then from there go triple wall. Now, a lot of times I get people who are buying my plans and they are looking at a building from scratch before they start a house or whatever, and they're saying, well, what about a masonry chimney? Can I just do the whole thing? And absolutely you can. And I actually think that leads to, some of the coolest looking heaters, for sure, the most beautiful builds. But the reason I don't always recommend it, or don't, recommend it or start from that starting point, is because there's very few people who are going to be able to really, retrofit a building with one of those. And for one thing, the weight is excessive. It definitely has to be carried down to the ground and onto a footing of some kind. And then on top of that, you're really just, a lot of that material up above that isn't really necessary. And while once it does heat up, it creates draft, you're also, putting heat up there where you really don't need it. So I think the metal single wall chimney flues actually do radiate it into the space a little bit better, even up high, before they finally, before it finally goes out, and whatever you're blowing out the top is whatever you're blowing out the top. So so to answer your question, yeah, I think single wall chimney going to double or triple wall outside is probably really the best way to go. Now, those flue tiles are super nice, but again, that's gonna be something that you build into a masonry type build. So there's that. So let's see. We've got, let's talk a little bit. David Swanson's here. I thought David here earlier. Let's take a look at what David's been working on. David, you've been awesome about sending me pics, and I really appreciate it. I think where you're at now is a great place to show the gang kind of what you've been working on. So let's see if I can make the photos work. I think they're going to be all screwed up, because like I said, I really messed up my I had all my screen settings all screwed up right before here. So let's see what happens. Look at that. I can probably fix this pretty quick. There we go. That's funny. I was really flustered, you guys, right before we started here. I was like, oh, I'm blowing it. So, all right. Okay, so, Jacob says, your plans are still waiting on my PC. We're fighting with regulations in Poland to renovate our wooden house. Oh, yeah. Inspectors and all that stuff. I'm sure that's no fun. Well, I hope you get to build it. And I hope you get to build it before too long. So Jeremiah says, I spend more time in elbow grease cutting floors and laying the footers than stacking bricks. No doubt. I mean, it's important. It's definitely the right way to do it. But you can avoid it in some of our smaller, builds. And so that's the thing, is as soon as you get into adding the masonry chimney, you definitely are into into footers and all that stuff. So hey, this is a pretty cool idea that David's got, and it's pretty close to my heart because when I started doing these stoves, I was kind of trying to fit everything into these barrels, and they're just such an amazing resource that we can find everywhere. But David had this idea of doing a riserless core within a barrel and just kind of splitting the barrel in half and using sort of the natural chamber of the barrel. He can kind of build the core inside there with ceramic fiber, but using the barrel as the outer structure, and in so doing giving himself kind of that exoskeleton pre-built. And so we talked about this a little bit on past chats. We've been sort of kicking this idea around, and I think it's a really fun idea. I think it's going to be really neat to see it burning, and I love it, David. I think it's great. So if you guys remember 2 weeks ago, our last chat, David was asking about a copper hinge for his door, and we all talked about it. We thought maybe he could make his own hinge, maybe weld some copper round bar in sections, inside of a door hinge or something like that. So David was super cool and got right to work after our last chat, and then started emailing me photos. And check it out. Here's this hinge, kind of just like we discussed, coming together. So, and in this case, I can't tell. I think you've got a standard steel door hinge there that you just kind of cut down a little bit to make it fit. But there's some copper round bar stuck in between there. And of course, you can see the pin about to go through. And this is how it all goes together. So I think that just came out so cool, David. Especially it was so neat after we were all talking about this, and then you just kind of got right to work and came up with this killer little work. So there's the door's seal. Got a nice fiberglass tape seal there. Really nice work, David. I think it's going to be great. So here it is starting to come together a little bit. So now you can see what's happening. We've got the copper door hinge here, which looks like it worked out great. I mean, that's got to be super stout and difficult. I can see what your challenge was. There's not much room here for a hinge. Now I see why you cut the hinge plate there. And what you guys aren't seeing is there will be a center divider here, right, to turn this into a riserless core. And I think we've got oh yeah, I'm just trying to click on the wrong part. We got another inside pick here. Yeah, so there's the beginning of the inside installation, and I don't think we have any more here. We don't. We just, so that's all we've got right now. But really cool build, David. I think that's so neat the way you combined the riserless core inside of there, because you really don't need much, do you? And it looks like you're using mostly wool, so that's a lot less expensive than the board. Your center divider is going to be a little bit tricky, but it shouldn't be too hard. And I think it's going to work out great. And it comes out about, if I'm not mistaken, it comes out about the equivalent of an 8-inch riserless core. And as you guys know, I've often been hesitant to recommend the riserless core as an 8-inch system because it kind of starts to get unwieldy. You need a lot in materials, and it can be difficult to span the top as the box starts to grow. But I think what David's done here is a neat way that addresses a lot of those issues and kind of makes them non-issues. So yeah, good job, David. Just like Tall Shadow says, I think that is fantastic work. And I don't know if you have any updates. I don't know if you're any farther along. It seems like you've been doing great at keeping me updated, so I'm sure that's about where you are. But I can't wait to see it burn and hear your experience with it and see how it comes together for you. So with all that said, we've got another a little more progress that we should look at here, if I can find it. What have I done? Give me a sec here. I think I must have sorted by something. Yeah, date modified. That's going to make it hard to find. There we are. So the other thing we want to look at here is we got. Okay, let me catch back up with chat here. I'm getting a little all over the place while I while I look for files on my computer. Swanson says next step is to cut a hole for the exhaust flue and the center divider with vent at back. Right? Yeah, exactly. With the internal size. Okay, so 10-inch flue pipe. Yeah, 10-inch flue pipe with 1-inch fiber blanket. So you'll have an insulated flue pipe coming out of there, which will be 8 inches diameter internally. So it sounds perfect. I think it's gonna be hot, is what it's gonna be. I'll be really interested to see. I expect that the barrel should be just fine, insulated from the inside and allowed to radiate from the outside. I don't see why that would be any issue. But perhaps it will, maybe do some deforming. I don't know. It'll be curious to see what happens. I mean, it's obviously structurally it's in a great shape, in that drum barrel shape. It would be hard for it to, not that hard. I mean, I guess we'll see what happens, when it gets really heated up, see how much it changes shape and all that. So, because I do think you're going to, put that thing to the test in terms of how hot it is, even through the insulation, because you're going to create such high temperatures within the insulation. So it's going to be cool though, man. I'm real excited to see what happens with it. So with that said, let's take a look at our good friend Belgian Gulch at Tom's Smoke Shack. So Tom couldn't be with us here today, but he's been keeping me updated on these photos, and I think I can probably even make that bigger for you guys. There. But boy, he's been just cruising along on this smoke shack, and I gotta tell you guys, I am so inspired by this. I just love it. And he made it look so easy, right? It's just some simple brick stacking here, those brick towers. The footing probably was a lot of work, but overall, I love this thing. So, I'm going to catch back up with chat real quick, and these guys are talking about the barrel heater. So, David Swanson says he's going to have a second barrel on top of the riser kind of thing as a radiator, and he says if it bends, replace for $55. Totally, yeah. I don't get me wrong. I wasn't thinking like there was going to be any problem with it. I'm really curious to see how it holds up. And yeah, you just replace it with another barrel, another drum, no problem. But I think it's going to be a really cool stove with the radiator on top of there. Man, it's going to throw some heat out, David. That's going to be very cool. So okay, going back to Tom's shack here, he has made amazing progress, and I just love the way this looks. So I don't know that this really, I think we get another stove view. Maybe not. Maybe we're just kind of looking at the shack. But you can see oh, there he is up there climbing around in the roof. I didn't even notice that before. Nice to see you there, friend. Love the smoke shack. I mean, it's just so dang cool. There's the stove. So that's what we couldn't see in there, was the barbecue brick oven. The Walker barbecue brick oven, which Tom's built, looks like pretty much right to plans there. And as you guys know, Tom runs Dragon Tech RMH, so he's a great resource for all you folks needing doors or hardware, and I think maybe even sometimes ceramic fiber insulation, secondary air pieces, RA330, all kinds of good stuff. So for sure, check out Dragon Tech RMH and Tom's work. But let's look at this thing right now. It's so, man, love it, Tom. Absolutely love it. Having my design there, in the centerpiece of your little smoke shack is something I'm really proud of. I really appreciate you, doing all that. And man, this thing is it's going to be the coolest thing. So, and Tom let me know that they were already eating really good out of the barbecue brick oven, so that just made me super happy to hear. Quite a roof structure. I know that lumber got a lot or went down in price quite a bit since April, so good job waiting. I'm sure those two side beams were spendy, but that's a really nice structure, man. It just looks fantastic. Can't wait to see some pictures of some food coming out of there. So there's that. So I hope that this is weird. Why is that? Oh, I see I can move myself. I got things so screwed up, didn't I? Oh man, sorry about all that, fellas. Looks like it's still kind of funky. Whatever. So yeah, doesn't that look nice? That door. Yeah, let's. I don't think I stayed on the door long enough. Yeah, that's Tom's oven door pull off, and just beautiful. And I think actually I don't think I'm doing him justice here. I think he has an actual door on this that I didn't show. Yeah, let's go for a little more photos. There it is. How about that? Tom, you'll have to let us know if you built that door. That is gorgeous. It looks like it's cedar. Yeah, Tall Shadow says Tom's shack is like a temple for the cool oven. It totally is, man. I'm telling you, I'm gonna copy his shack. I'm already 100% sure that I'm gonna do something really similar. I've already got my oven outside. I don't know if I can build my shack around it or if I have to move the oven. But I'm doing this, man. I just, like, I keep telling him, every time he sent me a thing, I've been like, I'm so inspired. And I don't know if he believes me, but I am inspired, man. I think that is the coolest little building. And, I don't know how many bricks. I'd love to, I wish he could be here, because I'd love to hear how many bricks went into this whole build. So my oven is, I think, a little over 200 brick. And, that's like... $100, right, from Home Depot. I think that's even delivered $100. So this thing, I mean, how many bricks are in there? Another 300 or 400 maybe. A couple $100 worth. It's just awesome. It's just so cool. So, and I just picture it. I know it's just a cooking shack for him, but I could see myself building a little one of those as like a little guest house or something. And once that oven is warm inside, if that thing's all, dried in and walled in, and it's going to be so cozy. And, he's in a cold area, so he can be out there cooking all year round. I mean, they're probably going to move into that thing. Maybe not, but it's beautiful. It really is, Tom. I'm just really inspired by the whole thing. So thanks for sharing all the photos and stuff. I can't wait to see it all the way done. But it's been really cool to come along with you for the ride here. There's a little cooler, little better shot of the oven. So as you can see, it's the firebox is down on the left hand side there, where he's got the firewood stacked, and then the oven door here is on the right, or facing us. So he's got his thermometer in there right at the food height, and you can see the insulation under the brick top. Really, what we talked about earlier, some strategic insulation helps to drive that heat down towards the cooking chamber and keep the oven hot without losing a lot of heat to the top, and also allows him the leeway of using some, whatever materials up top that don't need to be able to take super high heat. Really nice dressing of tiles around the bottom. In this design, again, I dictated concrete building units for the footer down there, so he's better than me with the aesthetics. He's covered those up with beautiful tiles, and then you start with the first layer of bricks down there, and man, what a great little thing. So oh geez, my mouse, hard to keep track of. Yeah, so there we go. That's the whole structure. So let me catch back up with you guys here. Yeah, Jacob says the door looks really nice. It really does. I really love the wood door, actually, on that. And Jeremiah says, a boiler builder told me sodium silicate is what he used to stiffen it or make a shell on the blanket. Yeah, Jeremiah, we've actually been aware of that. I mean, I think, it goes in and out, but sodium silicate is the main ingredient in the rigidizers that they sell for ceramic fiber or ceramic wool. And sodium silicate by itself will do a reasonable job of creating a refractory shell. But in my opinion, it really depends on what your goals are. Like in David's case, where it's like where it just needs to be rigid, so it isn't, so it has structural integrity and can just hold a shape like this rather than falling down like a blanket. Rigidizer is great for that. What Rigidizer doesn't do, which a lot of people used to ask me about a lot, is will it create like an abrasive resistant finish inside the firebox? And I just don't think it's strong enough for that, because it kind of just makes like an eggshell over what's still a soft backing, and so that the eggshell will just break into the soft backing. But sodium silicate does a really good job of just kind of creating that shell-like structure, and you can use it inside combustion chambers over ceramic fiberboard, ceramic wool, even cob perlite type structures. They help a lot with that. Like if you do like one of my early cast J tubes where I just used clay and perlite, you can use sodium silicate there, which I did use to help the mix, but you can also use it like as a coating to help harden the inside a little bit. Pretty handy material overall. So Tall Shadow says, I know he kept going back to Home Depot to get more bricks, but never was upset at having to do so. He seems like he doesn't probably get too upset about much, but he's great attitude for building stuff. And yeah, I'd be curious to hear what I like to hear, though, that he kept going back, because that means he didn't have a plan. And I like that a lot, because that's how I like to work too. I made the plans for all you guys, but only after I built it, wild style at first, and that's why I figured out it needed 200 bricks. And that's actually one of the biggest questions I had for him with regards to how many bricks, because I would do the same thing. I would just kind of start building the wall and see where I ended up. So Jeremiah says people reportedly spend the most time in the kitchen when at home. Totally think that that's true, and this would be a wonderful place to stay. And thinking that politicians in Europe are trying to kill all that beautiful projects is not nature friendly. I know, Jacob, exactly. So, it's so nice that we can do this kind of thing, actually, on that note, but do it in a way that's going to burn totally clean. So this little smoke shack is the kind of thing you could build somewhere that it would never give itself away, because it's probably, we call it a smoke shack, but it's probably not going to have visible smoke coming out the chimney almost ever. Right at startup, right at end. Maybe if you're really trying to smoke some pork or something, you'd put a little bit of wood chips in there, but when you do that, you want just the thinnest wisp of smoke anyways. So, yeah, this thing, if you did need to evade detection from European politicians, Jacob, this would be a good way to go. Oh, I know what you're referring to. You're referring to your home and your building permits. Yeah, and you're in a village, so I don't think you can just do whatever you want. They're gonna know. Well, so much for that idea. Tall Shadow says maybe the high ceiling is a loft for sleeping, so we wouldn't have to leave the kitchen. That's funny. We looked at those at the history of the masonry heaters. Do you guys remember the Russian stoves? I don't know if I brought up a really good photo, but Russian stoves traditionally were just the big fireplaces, masonry fireplaces, and traditionally the Russians would just climb on top of them and sleep. And it's funny because they never were built like something you'd climb on top of and sleep. They were built like a big heater with the little spot up there against the ceiling. And I just loved that they never bothered to change the design. They were like, no, we just sleep up there. They didn't bother to be like, we've now brought the bed down to our level or whatever. And they were just like happy for centuries to climb up 8 feet on top of the fireplace. So yeah, I think Tom could very well be sleeping up in the loft up there. Jeremiah says, is the DIY aspect that the establishment doesn't like. I think that's probably partly true, and Jacob says they're making a law against us making these projects on the edge of being legal. Well, I understand that. It's so frustrating. And then Jacob says, depends on how friendly your neighbors are. So yeah, the legal challenges to this are so frustrating everywhere, because we are exceeding the efficiency and cleanliness of most of the box stoves on the market, if not all of them. and you know, at the same time, we don't fit into the testing parameters that they use to test those stoves, and yeah, it's just a mess. You guys, we've been all over that one over and over again, but we still have some work to do on the legal parts for sure. And you know, I'm not sure what the holdup for you there, Jacob, is. If it's specific, if they're looking specifically at the combustion chamber and saying it's not acceptable, or if they're just looking at old masonry heaters. But if it's the former, like if they say you need a ASTM or ISPO certified, you know, combustion chamber, which a lot of times in those European regulations they want certifications. You might look to some of the masonry heater builders and look at something called the Eco Firebox, because I do know that at least in Austria and I think Germany, and you know, it seems like it would be heading towards Poland, there were some fireboxes that were, you know, had passed ASTM or whatever the standard body is, and had made those, you know, legal in some parts of Europe. So maybe there's something to look into there. Yeah, you need an exhaust certificate. Exactly. Yeah, you need it. That's it. So it's the same way here in my state. I'm just doing research, so I'm not really pushing the limits too much. But in my state too, it is if you were going to have a permitted structure, which I think you guys can probably look at my structure here and guess whether mine is or not. But yeah, you know, you must have tested, certified combustion chambers only that have a certificate of clean exhaust, and the only way you can get that, at least in my country, is going through the EPA's testing laboratories, using the EPA's testing protocols, and that testing protocol is designed around box stoves. They don't even start the test until 30 minutes after you light the fire. So it doesn't work for rocket mass heater type combustion units, because we're almost done burning by the time they turn on the tester. So they turn on the tester, we're past our peak burn. And anyways, we can go on and on and on, but yeah, and yep, you can make it more legal by using the catalysts, and yeah, it's a whole mess. So the interesting thing is the stove built to my plans will probably be cleaner than any of those things. So I don't know if it's possible to do it after the fact, or like build one outside and have someone come test it. I don't know what the ramifications are. But I'm certain that the stove would meet the requirements, but it's just that they need the manufacturers to do the testing beforehand so that the consumers can have the slip of paper. So, and for non-commercial building, that costs a lot for the exhaust certificate. Yeah, tons. I mean, that's one of the main reasons why I didn't go into commercially selling stoves when I came back from my big event in Washington, D.C. I thought that was what I wanted to do, and when I came back, I realized that there was no way I was going to be able to do that, because to test them was going to cost, you know, to get the certificate was going to cost more than I would ever make selling hundreds of them. So anyways, that's probably it for today, you guys. We've been going for about an hour, so I think that's enough. Thank you guys all so much for being here. Really appreciate it. It's really, really wonderful to be back on again with all you guys and have everyone's input and company and all that. So yeah, so thanks so much for another great show, you guys. And yeah, I don't have much else to say. So I guess with that said, I will hit the outgoing video, and I will see you guys next week. Thanks so much again, and I hope you guys have a great week. And I'll see you next week for episode 48. Yeah, I think so. All right, you guys. Have a good week. See ya.